Today's webinar is about the outcomes from SCEPTREplus for ornamental crops. It'll be about 2 hours, and it's covering previous and recent work from SCEPTREplus, specifically on ornamentals, and we'll be covering sort of pest disease and weed control within today's webinar. In terms of housekeeping, as I've just mentioned, hopefully everybody is on mute. If you'd like to ask a question, I will come to that in the next slide, but you can pose a question or raise a hand in chat. What we're hoping to do is to take perhaps 1 or 2 at the most questions at the end of each presentation, and then at the end of the actual webinar, if there are remaining questions, we'll cover them all at the end before we go. Today's webinar is going to be around about 2 hours, hopefully, including questions, and as Rosemary has already mentioned, it is being recorded. If you do require basis and Neroso points, there are basis and Neroso points for this webinar. Please send your details, including your name and your basis number, to Rosemary, and she will register on your behalf. So in terms of questions and presentations and future access, as I say, please turn cameras off and mute. If you'd like to ask a question, either raise your hand using the reactions icon or click on the chat and pose a question. And either myself or Rosemary will try and keep on top of the questions coming in, and then we'll pose questions at an appropriate point in the presentation. As I said, basis and Neroso points are available. PDF versions of the presentations will be available. Sorry, I just got rid of that. PDF versions of the presentations will be available at the end of. Sorry, they will be available shortly after the webinar is completed, and the webinar recording, which Rosemary is making, will also be made available on the Warwick Crop Centre website. And I believe Rosemary will be sending details around to all attendees if you want the PDF versions and to have access to the recorded version of the webinar in due course. So just picking up in today's programme, I'm doing my presentation and welcome. Unfortunately, Debbie can't be with us today, so Rosemary will be doing the introduction to the SCEPTREplus programme. It's just 1 or 2 slides just to introduce and give an overview of the SCEPTREplus programme itself. And then we'll be focused on pest, disease, pest and weed control elements from that said programme. And we'll have Catherine, Joanna speaking about various trials within that, looking at foliar diseases and control of diseases in narcissus. Pest control in terms of aphid, western flower thrips, two-spotted spider mite will be made by Jude, and also picking up on scarred and leafhopper. David is covering weed control in narcissus and cut flowers, and also an interaction between herbicides and grain type, which was a small extra trial which has generated some information. And then finally, but not least, Selchuk Kurtev will be summarising some of the work from the Cut Flower Centre, which is relevant to the audience today, including peony herbicide evaluation and downy mildew. And then hopefully at the end, if we can stay on time, we'll have about sort of 10-15 minutes for questions to all the presenters to pick up. Just as a quick introduction, for those who have not met our team today, unfortunately, Debbie, as I say, can't be with us, so please, the actual session will be covered by Rosemary, and unfortunately I haven't been able to sort of swap the slides around, but Catherine, the second slide, and Joe, the third slide along, will be covering the disease element. Jude, I'm sure many of you know Jude, in the bottom corner there, will be covering pest and disease, and then David and Selchuk. So without further ado, I think I will leave it there, Rosemary, and I'll pass over to you for the first presentation, introducing the SCEPTREplus programme. Thank you.
Many thanks, Wayne. Can you just unshare your slides, please? Thank you. Okay. So I'm going to share my slides with look. Can you see those, Wayne?
Yeah, if you go into presentation mode.
Yeah, brilliant. Okay, right. So good afternoon, everybody. So I'm Rosemary Collier from Warwick Crop Centre. I'm really sorry that, well, I'm really sorry Debbie can't join us, and she is rather unwell. And I was the science lead for SCEPTREplus, so I guess I'm giving, presenting the slides in that role, as it were. So the SCEPTREplus programme was between 2016 and 2022. It was extended by a further year than was originally planned, and that was because of COVID, because COVID affected so many of the trials. It covers all horticultural crops, so that's edible and non-edible crops. And the trials are focused on pest diseases and weeds that were considered to be high priority, and I'll say a bit more about that in a minute. The products that were tested must have a realistic chance of reaching the market, and there was a lot of consultation with the companies to identify these products. The total cost of the project was 1.7 million, and crop protection companies contributed approximately £160,000, and the cost of the ornamental sector was approximately £400,000. So the trials focused on ornamental crops, weeds, pests and diseases, and you're going to hear about all of those. There were 22 trials altogether, and that totaled up to 219 treatments. So a lot of products were evaluated. And just to say that some of the trials undertaken for the other sectors, for example, field vegetables, are also relevant in terms of the target pests and the products tested. So in terms of outcomes, then there was a certain amount of information on new crop protection strategies, so how new products might be used in the future. And the SCEPTREplus trials also provided a lot of evidence for emu applications. And the sort of evidence that was used to inform the choices of the targets for the trials, and also fed into the AHDB team for emu applications, were industry pest, disease and weed priorities. So those were obtained by consultation with the various crop groups. New and emerging pests and diseases that we were aware of. Emerging risks to existing crop protection programs, so withdrawal of certain products, risks of pesticide resistance, and then opportunities to broaden the range of minor crops for which plant protection products are available through emus. And the application for emus is a very complicated process. And it requires continuous liaison with individual growers, crop associations, agronomists, agrochemical companies, and also with our counterparts in continental Europe. So it is a pretty intensive process. And just to sort of give you a count up of the emus secured by AHDB for ornamentals since 2016, so since SCEPTREplus started, there have been a total of 61 emus. So those have mainly been insecticides, herbicides and fungicides, but also a couple of soil fumigants and plant growth regulators. And to date, it's been possible to secure emus that cover a broad range of ornamental crops from a single application. So I'll stop there. If anybody's got any questions, possibly Joe might be able to answer some of them better than me later on. And I'll stop sharing my slides.
Not a question, Rosemary, just a comment. Sam, we can all see you. Could you put your camera off, please, if you don't mind? And I know you've got a beautiful face there, but if you could switch the camera off, it'd be fantastic. Thank you.
Should be off now.
Yep, fine. Thank you.
Thank you. Thank you, Sam. Thank you for that, Rosemary. Can I now pass over to Catherine, who will be kicking off the disease control element, talking about foliar disease control and foliar disease control in Narcissus specifically. So over to you, Catherine, please.
Righto, can you hear me? Let me just put it into presentation mode. Okay, can you all hear me and see if that's okay? I'll assume yes. Okay.
Okay, well, great, thank you.
Okay, great, thank you. Okay, well, thanks very much for asking me to present some of the SCEPTREplus reports. I'll be looking at 4 different trials, actually 5, because one of them is a 2-year trial from the pathology perspective today. So it'll just be a brief overview of the work for each, and then I would encourage you to find the reports on the AHDB website to read the details further if you're interested in those particular trials. I'll also say now that although I'm presenting these projects on behalf of ADAS, I can't take the credit for actually having done the hard work on these. It was done by my ADAS colleagues, sort of past and present, some of who aren't with ADAS anymore, which is why you have me. And also there's the last trial it was run by Stockbridge Technology Centre. So in the following trials, there's 7 products which have emus for ornamentals already, and many of the projects sort of gathered the evidence for those to go through. And obviously some of these trials were sort of in 2018 and have gathered their emus since then. And there's 3 still in the pipeline. So the first project I want to talk about is the SP33, which was looking at sort of crop safety of downy mildew products for ornamentals. And downy mildew, is probably most of you know, are sort of fungus-like organisms that sort of include Pythium and Phytophthora. They're not quite the same as fungus, have a slightly different cell wall. And these can cause some serious losses in many floriculture and greenhouse crops. And these sort of present a particular challenge sometimes because they can be present but not particularly obvious. And so they're difficult to control with fungicides once they're established, but they can be cryptic. They're not the same as powdery mildews, and they sort of attack under different conditions and are susceptible to different classes of fungicides. And although they're very host specific and they can vary in their aggressiveness and symptoms in general, you'll see symptoms beginning off as a sort of a light yellow-green, light green, irregular leaf lesions that sort of become purpley brown and then sort of delimited by the leaf veins. And then in sort of humid conditions, you see the sort of characteristic downy fuzz underneath the leaves. And so the objective of this first trial, which was run at a nursery in Herefordshire, was just to assess the phytotoxicity of these applied products rather than sort of direct disease control, just to see their safety. Individual trials were established for each of the 7 species that were included because of their different husbandry requirements rather than lumping them all in together. They're all set up in a randomized block design, 4 reps of 10 treatments. And there were 6 conventional fungicides and 2 biopesticides included, with a standard of Fluebol Gold. And the assessments were looking at plant vigor and phytotoxicity. Oops, sorry, went a bit too far there. So jumping straight to the results of phytotoxicity, essentially none of them had any phytotoxic effects, which was good news, I guess. There was one particular product which didn't get taken forward, which was 9963, which left a residue on the trays. But other than that, there were no residues left on any of the plants by any of the products or any phytotoxicity. There was a little bit of botrytis that crept into this trial, and none of the products that were tested had any impact on that botrytis, which wouldn't be expected because it's a different sort of target. But 2 of the products which did come out of that trial is Ranman Top, which has an emu, relatively recently approved. That's a FRAC code 21 fungicide, has activity against oomycetes, and there was no phytotoxicity. There's a maximum of 6 treatments in a 12-month period, so that potentially offers some good control. There was also Prev Gold, which is doesn't have authorization yet, but is expected potentially in the short term. I think Joanna tells me that sort of short term means in the next year or 2. Essentially, that's a biological orange oil which works on contact and sort of desiccates the target, so that whether that's a pest or a disease. And from these trials, there's also 2 other products which are sort of in discussion for authorization. Essentially, from this trial, they all performed fine with respect to phytotoxicity. So coming to the next trial, SP32, this target was botrytis. Essentially, the rationale for doing the trial was that the number of actives was in decline. I think the loss of Roverall, its last end use by date was 2018. There were some crop safety issues. This trial was also conducted by Wyvale Nurseries in Hereford, looking at 9 different species, 10 treatments, 5 conventional and 2 biologicals, with using Signum as a standard. And so there were 9 different species which were included in the trial, quite sort of a nice range, including 2 ferns, as they're sort of known to be potentially susceptible to phytotoxicity. If we look at the treatments and assessments, I've sort of tried to signpost which ones have already got emus and which ones have got submitted. And so the orange ones, I guess it's good news that 6 out of the 8 trial treatments now have emus for use in ornamentals, and 1 other has been submitted and 1 is under discussion. I think, or maybe not, actually, sorry, that's wrong. Number 7 is not under discussion. That hasn't been taken forward. The plants were assessed 6 times at setup after each of the 4 applications, and then 14 days after the last application, and then they were assessed for incidence and severity of botrytis and phytotoxicity. And the trial ran between November and December in 2018. So jumping straight to the results, there was a low level of botrytis found on most of the species. On sedum and heuchera, there was a significant reduction in severity compared to the untreated control. The data shown here is from the last assessment. On the other species, it didn't see much of an impact at all. In sedum, there was 3 out of the 9 test products that had a significantly positive impact on botrytis, and that was lunar privilege, Cercadis, and this of 9926, which was is currently in sort of the application process. And these are all of a similar class of fungi, so particularly effective in this situation. For heuchera, all of them had a significant impact apart from the control, which is quite interesting. But again, it was these 3, lunar privilege and Cercadis, which happened to be the best performing, but they all had a significantly positive impact on controlling botrytis. In terms of phytotoxicity, they were pretty much all within commercially acceptable levels. On most of the species, there was no problem, but on the ferns, there was some slight browning phytotoxicity, but all within acceptable levels. So moving to a second trial, this is actually 2 trials because it was multi-year. This is looking at narcissus. This was targets for the study were white mold and smolder in narcissus, which are both common foliar diseases affecting narcissus in the UK. Average losses are predicted to be about 10% of bulb yield and 5% of overall flower production. And as with many of the trials, the objective was to identify crop-safe alternatives as the number of actives are in decline. And for smolders, the infection develops from black sclerotia on infected bulbs, and the early leaves emerge through the bulk. Through the bulb, become infected and develop into primary infectors, and then those sort of emerging shoots then become infected and then sort of spread the inoculum around via wind and water and splash. Periods of hail damage and the time immediately after handpicking seem to be the windows of high risk infection, and wet weather will exacerbate symptom development. So I think it's 6 hours of leaf wetness with cool temperatures are optimal for infection to occur. A normal spray program would be 4 fungicides with 2 different modes of action, and that would be sort of targeting emergence, but then also looking at sort of apply during flowering, and then also following picking to protect any sort of newly wounded tissue. This was a 2-year trial, so the first year was really looking at products to look at efficacy, and then the second year was looking at how to incorporate those and what the optimal program might be to use those. The tracker was used as the standard control alongside an untreated control, of course. In green bars represent those which are significantly different from the untreated control. And you can see that here, sort of, again, I've coded them the same. So where orange, it's where they have an emu already, and then yellow box here is where they have, it's in the application process. And so you can see that for both white mold and smolder, there are some pretty positive impacts on the disease. There was no phytotoxicity of any particular commercial concern. You can see that potentially Some were better than others. Frupica, Prolectus and Sonata in smolder weren't as good as the others. Tracker and Lunar Privilege performed the best. In white mold, Lunar Privilege was by far the best and better than the standard control. Cicadas performed very well. Prolectus also particularly good, and Sonata, well, Prolectus probably the worst, but still better than the control. In this case, Frupica didn't do particularly well. It wasn't significantly different, although it looks like there's a trend towards less disease, but it was significantly different in smolder. The two remaining products, 9863, which you can see here, and 9862, they have emus in discussion, so they're potentially in the pipeline as well. So then the sort of promising ones were carried over to treatment crows in the second year of the trial. And this trial was conducted by J.H. Richards and Sons in Cornwall, grown to commercial standards, apart from the application of fungicides, which the ADAS team applied by hand. And you can see that sort of they're put into sort of rotation. Most of them are sort of either already emus or not. Similar sort of a regime, looking at incidence and severity and crop safety, and St. Patrick's Day was used. This trial was conducted in January to April 2020. So in this particular trial, it was based on natural infection. So white mold and smolder developed naturally from naturally occurring sources of infection. White mold was reportedly similar to the previous year, whereas smolder was there was a less disease pressure than the previous year. I think also it's important to note that in this trial, the crop has already started to emerge before the first treatment, so potentially infection may have occurred during that time, and so it may have had an impact on sort of the efficacy of these particular products on white mold. You can see that there was no significant difference between treatments at any time point in incidence or severity, unfortunately. Whereas in smolder, there was some significant differences, but it was only at one of the time points out of those measured. And that was this one, 21 days after the second treatment application. But you can see that with the exception of Circadis, all of the products had a good impact. I don't think any of them, I think maybe it's just Sonata in the first sort of regime was comparable with the standard. And there was no phytotoxicity as far as I'm aware. So to conclude, this first year of trials found that the incidence and severity of white mold and smolder could be reduced with the products tested. Promising products were taken forward. And there were no significant differences in white mold control or smolder for any of the programs in particular, apart from at that third assessment. And there were no phytotoxicity concerns. So just to summarise the products that were featured in those last two trials that already have emus in place, we have a Frupica, which is a FRAC 9. It's listed for action against botrytis and powdery mildew. In the botrytis trial, it didn't do particularly well on sedum and was worse than the untreated control, but was comparable with the others on Vajra. So, and in the Narcissus trial, it did have a significant positive impact on smolder, but again, was probably the least effective of those in that trial. It can be applied twice per crop, but only between May and September. Lunar Privilege is a FRAC 7. It's listed as having a medium to high risk of resistance, and so requires quite sort of a good resistance management to keep it effective. It's listed for use against powdery mildew and botrytis, and it was one of the best products in SP32, the botrytis trial. In the Narcissus trial, it was also the best of the lineup against both white mold and smolder in the efficacy trial. So it potentially is quite a good product to consider for that use. Prolectus is a FRAC 17. It's also listed for control of botrytis, and was probably middle of the pack of those tested in this trial. It gave a 55% reduction of botrytis in Vajra, but not significant control in sedum or the others trials. But I did find out that in another SCEPTREplus trial, it gave sort of 80% control of a Tritotinia species. And it also gave good control of white mold and smolder, but was the least effective of the lineup in that particular trial. That can be used 3 times a year with a 1-day harvest interval and only between March and September. Although there is an application submitted to bring forward those application dates, I believe. Cicadas, the last one here, is FREC 7. It's listed for use against botrytis and powdery mildew and smolder, only used between April and September. And this was one of the better ones in the Narcissus trial, where it reduced smolder by 76%. And it was sort of middle of the pack in the botrytis trial, where it reduced severity in horticulture by 70%. It's also worth noting that several of these have an aquatic buffer zone sort of requirement within the EMU. So it's, as always, it's important to read the label and check out the requirements before using them. So then moving on to the two biologicals which have EMUs approved, there's Amulo XWG, which is a bacillus species that I'm not going to pronounce on a webinar. It's listed for a lot of different pathogens and was one of the ones tested in the botrytis trial, where it did reasonably well. It was comparable with Signum on sedum and comparable with all the other treatments on Vojera, which is and so it seems to have a significant impact on botrytis. It can be used up to 6 times a year between March and October and all year when protected. The other was Sonata, another species of bacillus listed against for use on powdery mildew and white mold and smolder on Narcissus. It was in both of the trials that I've just gone through. And it had a pretty good impact on botrytis and was comparable with the other treatments, but it wasn't the best performing. So it did a job, but not the best job. In Narcissus, it was quite efficacious against white mold and smolder, but again, not the best in the pack. But it also did pretty well sort of in the programs. So I think there are some good options out there and available for use, which is good news, I think. So this just brings me finally to a trial that was conducted by researchers at Stockbridge Technology Centre, Laura Branfield and Aliana Cairns. So I'll just give you a quick summary. Powdery mildew is one of the priority targets for many ornamental growers, as you know, and it can be quite damaging and reduce the crop value. The objective was to compare the use of biopesticides individually and in combination against a standard fungicide program to see what might be the most effective. In this trial, there was lunar privilege as a conventional with an EMU, and which now has an EMU, and a variety of other biological products such as Phytosave, Romeo, Sonata, and AQ10. And the host was a honeysuckle. So looking at the trial, said that there were 9 different treatments tested against an untreated control. One of those was a standard conventional fungicide rotation. It was an inoculated trial, so 180 plants were inoculated with powdery mildew and kept and used as infector plants and placed throughout the trial after the first application, together with a fan to spread the inoculum to try and really challenge the plants within the trial. And so then looking at the results, we have disease severity over time on the left and at the final assessment on the right. There was no phytotoxicity observed during the trial. In the left-hand graph over time, you can see that the untreated control is the blue line at the top, and treatments 2 to 10 have all got reduced disease severity. And this was statistically significant from the first week after the first appearance of disease. On the right, at the final assessment, all the treatments were significantly different from the untreated control. Lunar privilege was the best trial, but not quite as good as the standard, but still pretty good, I would say. And the other single products didn't give us good control, although still better than the untreated and significantly so. But the combinations of biological treatments were all much substantially more effective, which I think you can sort of see along here. As in the previous study, 9926, which was used singly here, not in one of the combinations. I don't believe it was. It has been submitted for EMU approval, so it's in the pipeline. So I think the report sort of suggests that biocontrols, when used in combination as a spray program, can significantly reduce disease and hold their own against commercial fungicide programs. So that just leaves me just to acknowledge the people who worked on these projects. The RSK ADAS team, Agrichem companies, AHDB, of course, the host nurseries, Wyvale and JH Richards and Sons, and also Stockbridge Technology Centre. I think it's my last slide. So thank you.
Thank you, Catherine. Do we have any immediate questions for Catherine? I can't see anything in the chat or any hands, unless you've spied anything, Rosemary. Just to sort of say...
No, I haven't spied anything.
Just to sort of say, I think we were worried a few years ago with the demise of Rodrel. It was a mainstay for many growers and a go-to in terms of an eradicant for botrytis. So it's nice to see we've actually generated, or the trial has generated quite a wide range of alternatives there. And I know products like Lunar Privilege have been widely adopted by many growers, and I think many people are getting successful use from that. Just bear in mind in terms of treatment and time restrictions, as Catherine has said there, it does make creating programs a little bit more difficult nowadays, unfortunately. And I think we shouldn't underestimate the use of biologicals in programs going forward. I think as the products become more restricted, then we'll need the biologicals to use within programs to make sure we're maintaining the control of diseases in an appropriate way, and to keep our key eradicants, well, to make sure they're not excessively used, so that they remain effective for future and for future control of botrytis and other similar sort of foliar diseases like powdery mildew. So if we still not got any questions, thank you, Catherine. If we can move on to Joe, who will be looking specifically at Fusarium in Narcissus and perhaps one or two other points as well during our presentation. So Joe, over to yourself. Thank you.
Thanks, Wayne. Thanks, Catherine. I'm just going to share my presentation. Hopefully you can see that okay. Let me know if not. Okay, so my name's Jo McTighe. I work for AHDB on the crop protection team, the EMU team. I'm going to talk to you today about SP45, Fusarium in Narcissus. Now, John Clarkson at Warwick conducted this trial. He can't be with us today, so I'm going to present on this trial, and it'll probably have a more regulatory perspective, looking at sort of the barriers to authorization and how we work with the results that are coming out of these trials. So as I say, I work on the crop protection team. There are 4 of us on the team, myself, Kim, Carlos and Grace, and we all have our own individual crop responsibilities. So one of mine is ornamentals, which is why I'm here talking to you today. I also look after fruiting veg and mushrooms. And within the team, we apply for EMUs, we apply for emergency authorizations, we manage the residue trials associated with edible crops, we manage efficacy trials, and we look after the crop risk registers that each crop group holds. The team currently has a remit and resource to continue working until March 2023, and we're aware that there's an industry-led push to establish a new company to hopefully take on the EMU service past that. The team have recently produced a video, and it's published on our website, and this is just to give you more of an idea and an overview of what the EMU team does and how we manage our EMUs. It's worth mentioning that we also have Debbie and Nat still working with us. They are looking after the ongoing research and making sure that all of the reports are put up onto the website. And the website is now an archive website. It's been taken away from the main horticulture website, and that archive website will be maintained past March 2023 for you to access all the previous research that's been done, the fact sheets, the crop walker guides, everything that's been done hopefully will be maintained on there for access. So moving on to Fusarium in Narcissus, and when we talk about Fusarium in Narcissus, we're talking about Fusarium oxysporum narcissi, and it affects the bulbs. So the Fusarium affects the roots and the basal plates of the bulbs, and what we see is soft rotting bulbs, which affect the sprouting leaves and weakens the flowers that come afterwards. Now, in the past, growers have dealt with Fusarium by applying a fungicide or a biocide in with a hot water treatment. Now, the hot water treatment is generally done to control nematodes. Wooden crates filled with bulbs are placed in these tanks and dipped for about 3 hours at 44 degrees Celsius. As I say, this is mainly to control for nematodes, but in the past, fungicides have been put into the tanks. So chlorothalonil, which is now the active has been withdrawn, and also thiabenosol has been used in the past, but unfortunately we've lost that product as well. Growers have also used formaldehyde in the past. I think FAM 30 still is available, but there's a bit of an issue with the iodine depleting under a high bioload. And by high bioload, I mean that these tanks can get a bit dirty over time. You're sort of putting crates of narcissus in and out, so you can get some sort of soil build-up and bulb scale debris as well. If you're interested in finding out more about the hot water treatment of daffodil bulbs, there's a fact sheet on our website. Just before I come to SP45, it's worth noting that the SCEPTREplus programme built on other research that's been done over the years, and as I mentioned, we've built these new web pages, which are very crop specific. So there'll be a web page for cut flowers, a web page for bedding and pot plants, for hardy nursery stock, and each one of those will list out the research that's been done for each of those crops. So this is just the research that's been done looking at basal rot and nematodes and dipping treatments in bulbs in the past. And as I say, we conducted SP45 to build on that research and look specifically at fungicides that potentially could be used in a hot water treatment. And this was conducted in 2019-2020 by John Clarkson at Warwick Crop Centre. And we looked at 9 products, 6 of them were conventional, 3 of them were microbiological. And after dipping, the bulbs were placed in inoculated compost and then assessed to see how the fusarium infected them. So you can see we used Storate Excel as a standard, and then we had 2 other products, this 9820 and 9819, which were both effective. At the end, we've got 2 other columns where the soil wasn't inoculated, so again, we didn't find any fusarium. Unfortunately, this product Switch, which was also trialled, this does actually have an EMU for this particular use, but as you can see in this trial, it wasn't very effective at controlling the fusarium, so we looked to take the other 3 products forward. Now, as I say, I wanted to concentrate on why we haven't obtained EMUs for these 3 products yet. So I'm just going to talk about each one in a little bit of detail. So one of them was Mirage, which is prochlorase, and this controlled fusarium by about 85%. And we trialled it at the Netherlands authorised rate. We know it works in the Netherlands. In the past, we might have been able to do a mutual recognition, essentially transferring the Netherlands use over to a GB use. Since Brexit, we're no longer able to do that. So generally, when we apply for an EMU in GB, we have to match the authorisation as it already is for another crop. So for instance, for prochlorase, Mirage, it is generally applied to a cereal as a spray application. So the application we're trying to do as a bulb dip is very different. So when we put in for the application for an EMU, we were denied it, and the response came back was that the soil loading was too high. So essentially, when it's used in cereals, it would be applied to the foliage, and a lot of the fungicide would be taken up by the foliage. Obviously, when we're dipping the bulbs and then putting them straight into the soil, that's assumed to be 100% of the fungicide going into the soil, which might then be available for leaching into groundwater. So that's why we weren't able to obtain that EMU. We did try again with Mirage. We did try it at a half tested rate, so trying to take into account that foliar interception. And we also provided some bulb uptake data. So when we did the trial, we looked to see how much water was taken up by the bulbs and extrapolated how much fungicide therefore would be in the bulbs when they went into the soil. Again, the EMU application was denied for the same reason that the soil loading was too high. Of course, now we know that prochlorase is at risk of non-renewal in GB. There's the approval has already been withdrawn in the EU, and we'll likely see the products being withdrawn. So we won't be taking that one any further. A second product which was useful, which we used as a standard, was Storate Excel. So we know from years of experience that thiabendazole works from using Storate Clear. We trialled the rate that we used as per Storate Clear. And again, this is too high to fall within the risk envelope that's associated with Storate Excel. So the only authorization for thiabendazole at the moment is as a crate application, as a spray to a crate. So essentially the seed potatoes are within a wooden crate and the spray is applied over the top, and the rate is much lower than we used to use for Storate Clear. It's about 1/10 of the rate. So potentially we could look at that lower rate and see if that's useful. Potentially we could look at a spray to crate application. At present, though, the product is frozen for reauthorization, and we can't make any applications for it anyway until it comes through that process. The third product, and the product that was the most effective, was 9819. Again, the child rates were a bit higher than the used rate in the UK. So we'd looked at the Netherlands rate. This is a product we are still inactive, we're still interested in. And I will come back to that in a minute. We haven't been able to apply for an EMU for it at present, but we are looking to take it forward in a different way. And then, as I mentioned, we looked at switch as well, which unfortunately had not great efficacy. So it's worth mentioning that we've been looking at alternatives to bulb dips as well, so fungicide dips. So we've been looking at biocide dips as well. So back in 2010, 2011, Gordon Hanks looked at chlorine dioxide and did some lab tests and some small-scale tank trials to see if chlorine dioxide might be an option to use in the tanks. And then when we started losing products, we looked at this again in 2020. And we found that chlorine dioxide dosing is effective against the fusarium spores and against the development of basal rots. But again, we found that high bioload, that dirty dip, can reduce the efficacy. So that the system really needs to be kept as clean as possible if chlorine dioxide is to work. The field trials showed that there was no adverse effects on the flower production, no phytotoxicity. However, it does require the installation of an automated chlorine dioxide delivery system. So this maintains the chlorine dioxide at a steady level within the tank. And there's obviously a cost associated with that. But the report's available on the website if anyone were interested in looking at that as an option. Other options that we've been looking at as an alternative is using fungicides that are already used as straight to soil products. So given this problem that we're having with applying a product that would normally be used as a cereal foliar spray, we thought we'd look at products that are already authorised to go straight into the soil. So we've been looking at seed potato products. So we've looked across at the Netherlands to see what they're using, and we've also looked at seed potato products. These can be applied while the potatoes are going across the roller table, and they can also be applied as a spray to grate, which we discussed earlier with Storage Excel. Potentially we could take that through for an EMU. And we also looked at products that are applied at planting in furrow. And this is the option that we are going to take forward for a trial this year. And in fact, the bulbs are already in the ground. So the University of Warwick is leading on this one. And because of the AHDB situation, with work having to end by March 2023, Hutchinson's are partnered with us, and they will keep the field trial going until the end of 2024, because generally these bulbs will stay in the ground for at least 2 years. So this trial will keep going for a couple of years before the bulbs are dug up to assess for fusarium. We are also conducting a lab study, and this will end by the end of March 2023. So we'll have an initial idea about the efficacy of these products. And we're looking at 7 products. 2 of them are biologicals, and one of them is a product which is similar to that very effective 9819. And we haven't given up completely on gaining a hot water bulb dip. So that product that's similar to 9819, we are going to be looking at that again. We are including 3 treatments within the trial, which will include bulbs that have been hot water dipped, and we're looking at 3 rates of the product. And these are all lower and more equivalent to the authorised rate that we already have in GB. What we're also going to be doing is sending off some of those dipped bulbs for analysis. This will give us a really good indication of how much residue is actually within the bulb, and that way we can get a better idea about how much might be available to leach into the soil. And hopefully this means that we'll be able to take this product or a similar product through for an EMU. And I think that's all I had to say to you today. Thank you so much to John Clarkson and his team at Warwick. I hope that's given you sort of an idea about how we work with the results that we get from these SCEPTREplus trials, and how we try to overcome some of the regulatory barriers. also how long it can sometimes take to get to these emus, and just the way we try and think about finding different solutions and alternatives. I think there might be a few minutes for questions. I won't be available at the end of the webinar, I'm afraid, so if there are any questions, either you can ask them now or you can email me on the address there. Thank you.
Thank you, Jo. Any questions, either chat or sort of verbal questions for Jo, please?
Can't spot any.
If not, Jo, I'm really sorry to put you on the spot on this, but can you extrapolate a little bit more about the future of emus and where it might go sort of next year onwards?
So obviously DEFRA are telling us this, it needs to come from industry, and we're well aware that industry are working really hard to establish this company. Our understanding is that a future emu service might be funded by voluntary subscription. We are really keen to see this service work, so we are providing as much detail to DEFRA and to the people who are sort of looking to set up this company about what we do and how we go about doing it. We are starting to talk about how we might transfer data and knowledge across. So yes, we're working with everybody involved and you know, really trying to get it up and running and trying to make sure that there's a bit of a seamless, well, I don't know if it'll be seamless, but hopefully trying to get the transition to be as seamless as possible if it does happen.
Thank you for that, Jo. I know it's a difficult thing to sort of cover, and there's lots of unknowns, and working on, well, as one of the people working on the other side of the equation, I can sort of say, yes, we are, as an industry, we are trying to get various crop associations together, we are trying to get monies together, and we are trying to work with various bodies to sort of form the company and to hopefully bring the expertise across and to retain it in the industry. As you say, it's very much in discussion at the moment, and there's a long way to go, but there is the willingness from industry to do so, and hopefully there'll be the willingness from the ornamental sector as well to sort of back this and to make sure that we do keep the expertise within the industry. So thank you for all your work you've done so far, and hopefully for work in the future as well.
Thank you, Wayne.
With that, can we now move on to pest control, and can I ask Jude, if she doesn't mind, to lead off? Well, she's a sole speaker, so can we cover developments with key pest control, Jude, if you don't mind, please? Thank you.
Okay, can you see that?
I can. Can you just go into presenter mode? Fantastic.
Okay, thanks, Wayne. So I'll be talking about the pest control work on ornamentals that has been done in SCEPTREplus. So I'm going to be covering 5 projects: aphids on hardy nursery stock, western flower thrips on protected ornamentals, 2 spotted spider mite on hardy nursery stock, Sierraden shawflies, and leafhopper on protected herbs. I've included this one because leafhopper can also be a problem on some ornamental crops. I'm only going to be talking about statistically significant results and those of named products. So I'm not going to give you lots of results about coded products that won't be meaning anything to you. So I'm going to start off with aphids on hardy nursery stock. This trial was done at AHDB Boxworth by my colleague Alicia Bartell here. It was done on Hebe. And it was done in one of our polytunnels in these insect-proof cages. Inside every cage, each cage was a plot, had Hebe plants that we infested with Aphis gossypii, the melon and cotton aphid, which, as you know, is resistant to quite a few conventional pesticides. It tends to sort of live on the stems of the plant. You can see them all crowded on here. But during the trial, we got a natural infestation of peach potato aphid, this one here, Mysis persicae. So this trial, if you like, gave us 2 pests for the price of 1, because we were able to do assessments on both of them. So we had 7 treatments, including an untreated control, and we used main man as our industry standard. And the most effective treatment against both species is not yet approved in the UK. That's the only mention I'm going to be giving of a coded product, but we're hoping that will be approved very soon. So watch this space. And the other one I can talk about is a bioprotectant, Eradicote Max, which is the new formulation of Eradicote and Majestic. They're all maltodextrin. They're all approved at the moment on permanently protected ornamentals, but Eradicote and Majestic are going to be phased out and replaced with Eradicote Max, which is an improved formulation of maltodextrin, which is supposed to be better against aphids than the others. It gave us 52% reduction in Mysis persicae 3 days after the 3rd application, but it didn't have any effect on Aphis gossypii. And that's probably because this aphid is covered in a waxy covering, and any contact materials like Eradicote Max literally bounce off and they're not very effective. So that's probably why. But this product was effective against both species. So moving on to Western flower thrips, which you're all familiar with. This trial was done again at AHDB Boxworth. You can see my colleague Kerry Boardman here, who did all the practical work on the trial. It was done in our glasshouse compartments, again in insect-proof cages. Each cage was a plot containing verbena plants, which we infested with Western flower thrips adults. We had 8 treatments, including a water control, and we started our treatments at the first damage by thrips to the flowers, which you can see here. So a summary of the results. So I've given the products here, the number of applications and how often we did them. And I've just included some of the results here, which was percentage reduction in Western flower thrips adults per flower, 21 and 28 days after the first treatment. And overall, the most effective product was azatin, which is azadirachtin. It's a bioprotectant derived from the neem tree. And you can see it gave over 90% reduction in Western flower thrips throughout the trial period. It is approved on ornamentals under permanent protection, and many of you I know are now using that successfully for Western flower thrips control. So the second most effective product was Mainspring. This is a conventional pesticide. It's cyantraniliprole. It has been approved on ornamentals under permanent protection for a while, but only on ornamentals grown in inert growing media, and there's not a lot of those around. But you'll be pleased to know that Mainspring is going to be launched next month by Syngenta. Some of you will be going to the launch, I'm sure. It can now be used in regular growing plants grown in regular growing media. And in this trial, we tank mixed it with a tracker. A tracker is a sugars-based product available from Coppert. And that was at the request of the manufacturer of Mainspring. They asked us to do that for improved efficacy against Western flower thrips. And you can see it gave 64% control on this assessment date, which statistically was actually equally effective as azatin, and 68% at the end of the trial. So that'll be one you'll soon be able to start using and getting some experience for yourself. So the other 2 products that gave efficacy were 2 bioprotectants, Flipper and Majestic, both of which act on contact. On this assessment date, they were actually as effective as azatin and Mainspring. I was surprised how effective they were actually, but at the end of the trial, on the 28-day assessment, they didn't give control, and that's because by then Western flower thrips numbers had built up to quite high numbers in the untreated controls. So I would say that don't rely on these products if you've got a real western flower thrips problem, but they can be useful at lower numbers of thrips. So all these products have either got an approval or an EMU for use on protected ornamentals. And we didn't have any phytotoxic effects. In fact, in none of the trials I'm talking about this afternoon, we didn't see any phytotoxicity. So moving on to two-spotted spider mite on hardy nursery stock. This trial was done by Jen Banfield-Zanin at Stockbridge Technology Centre on Choisia in a unheated glass house. There were 8 treatments, including a water control, and Flipper was used as the industry standard. So one thing I think you should bear in mind about this trial is that low numbers of spider mite developed on the plants throughout the trial. Even on the control untreated plots, there was less than 1 spider mite per plant. So very low infestation. So I think it's quite difficult to draw any firm conclusions on efficacy of any of the treatments in this trial. But one I can mention is Botanigard. That's based on Beauveria bassiana, the entomopathogenic fungus. That gave 96% reduction in numbers of spider mites 7 days after the 3rd treatment. Botanigard has got an EMU for use on both outdoor and protected ornamentals, and we do know that Beauveria will control spider mite if applied under the right conditions. So that's all on that trial. Moving on to cearid and shoreflies and so-called potworms on protected ornamentals. Most of you will be familiar, I know, with cearid and shoreflies. Potworm, it's not really a worm. It's the adult looks a bit like a large cearid fly, and the larvae are a particular pest of orchids, particularly Phalaenopsis. So unless you grow those, you probably won't even have heard of these. So in this project, the aim was to review knowledge on current and potential control methods for all these targets, to do a trial on novel controls for cearid fly, and to visit Wageningen in the Netherlands to discuss their research on potworm on orchids. So the review was completed in 2018, and there's a link to the report here. In that, we collated all current options for cearid shorefly and potworms, including commercially available and naturally occurring biocontrols, such as this natural occurring fungus on cearid flies, Furia ceari, and the naturally occurring parasitoid for shorefly. So more about all these can be found in this report and also in the fact sheet that I wrote for AHDB earlier this year, not as part of the SCEPTREplus programme, but it includes all the current available control methods for cearid and shoreflies. So we did do a trial on novel controls for cearid fly in 2019. We used Nemesis, Steinema feltii, and many of you I know will be using these nematodes routinely for cearid fly control on your nursery. So that was the industry standard. And one particular one I was interested in is this product Natural, which is Bacillus thuringiensis subspecies israelensis, which has activity against fly larvae. And that has been approved for a while now, for use for cearid fly control on protected ornamentals, but we've never actually included it in a trial before. And we also included azotin and pitcher, which are approved for use against other pests on ornamentals, and our review suggested they might have potential control of cearid flies. But it was very disappointing. We didn't get enough cearid flies in our untreated controls or our water treated controls to give significant effects of treatment. So I'm sorry, I can't really tell you how effective any of these were, but what I would say is if you fancy having a go at Natural, it's out there. So if you have a go, and I'd be very interested to hear how you get on with it. So as final part of this project, my colleague Alicia and I visited Wageningen. We went with 2 growers from Double H who grow Phalaenopsis orchids. That's Howard and Malcolm. And we discussed with Marjolaine over there all the research that they've done on potworm, hoping that we might find the answer. But unfortunately, all the work that's been done at Wageningen has shown so far that there isn't a currently available biological or chemical control for this pest. The report is, you can follow the link there. However, they did identify this natural parasitoid Megastylus, which completely wiped out potworm on one Dutch nursery, so it was very effective. However, it's not been found again since. Because it sort of annihilated its host, and it's very difficult to rear, so it's not available commercially. But if we find that naturally occurring in the UK, I think that's going to be the answer to potworm. In the meantime, growers are having to cover their Phalaenopsis with nets to keep the adult potworms off. That seems to be the only thing they can do at the moment. So finally then, leafhopper. This trial was done by my colleague Pete Seymour on sage, and this is the leafhopper you get on protected herbs usually. It's the so-called sage leafhopper. Its proper common name is the chrysanthemum leafhopper, Eucterix melissae. It was done in one of our polytunnels, again in insect-proof cages. Each cage had sage plants which we artificially infested with the leafhopper adults. We had 7 treatments, including an untreated control, and we used Gazelle as our industry standard. So this is a summary of the results. All the treatments reduced leafhoppers and damage, so we were really pleased with this result actually, because leafhopper can be a real pain to control sometimes. The industry standard Gazelle was definitely the best treatment, and we only made one application, and it gave 96% reduction in leafhopper adults 22 days after that treatment. And it is got an EMU on outdoor and protected herbs, and it's also got approval on outdoor and protected ornamentals. Now some ornamentals like sages do get this species of leafhopper, but on ornamentals, quite often you get a completely different species, the glasshouse leafhopper. So although I think you could use these results as an indication of whether they would also control glasshouse leafhopper, I can't really guarantee that because we've only tested them against this one. So Sequoia sulfoxaflor, so that's a conventional insecticide that's approved for use for aphid control on permanently protected ornamentals. That also gave us, these 3 were all equally effective but not as good as Gazelle, but it gave useful control, 63%. And Prev Gold, which has already been mentioned, this is a bioprotectant based on orange oil, that also gave equal control to Sequoia, and that's now approved on peppers and chilies under permanent protection, and we're hoping that that will be extended to ornamentals soon. And I've already mentioned Eradicote Max, that also gave similar levels of control to these 2 products, and that's approved on all edible and non-edible crops under permanent protection. So I think some useful products there for leafhopper control. And as final thing we did on this project was test the attraction of leafhopper adults to different coloured sticky traps, because one company was claiming that red sticky traps were more attractive to leafhoppers than blue or yellow. So we put a load of sage plants infested with leafhoppers in that sort of tent cage and surrounded it by replicate different coloured traps. And we made 2 assessments over 2 6-day periods of leafhopper adults on the traps. On the first 6-day period, there were significantly more leafhoppers on the yellow. And in the second 6-day period, when numbers of leafhoppers were lower, there was no differences between numbers on any of these colours. So from that experiment, I would say that you may as well use yellow because it seemed to be more effective in a high leafhopper density and just as good as blue or red at a low leafhopper density. So just to say thanks to AHDB for funding the work, the product manufacturers for providing the products, and my colleagues in ADAS and Stockbridge Technology Centre for doing the work. And thank you for listening.
Thank you, Jude. Any questions for Jude on any of the subject matter she covered? Aphid, western flower thrips, spider mite control, and leafhopper and scarrid.
I've got a couple of questions, if that's okay.
Yeah. Sorry. Who? Can you just introduce yourself, please?
It's Sam.
Okay,
Do you want me to
Sam.
turn my camera back on?
No. So just fire away the question, please.
So we're obviously protected herbs, but a bit of ornamentals. Is there any work going for azotin for protected herbs? Because thrips have been a real headache this year. Because it's kind of a biopesticide, isn't it? That's my.
Oh yeah, definitely. Yes.
So I feel like we ought to have it, but we don't.
Yeah. I'm not aware of any myself. Have to contact the manufacturer to see if they know of any work on protected herbs. But yeah, I'm not aware of any myself.
Okay, and then you're talking about spider mite control. Does that would that impact your cucumerus and let's say put out mondorensis and things like that? Is that also going to negatively impact your bio?
Sorry, you said spider mite control?
Yeah.
Which product are you talking about, Sam?
I've forgotten now, but it was the one that had good control. It was a chemical and it had good control of spider mite.
Oh right,
which is obviously
trial.
Interesting.
Yeah.
But then I was wondering what it would do to our bio.
Right. Oh, Bavaria. Yeah.
Yeah.
That one, Botanicard. Yeah. Well, that is considered to be pretty safe in IPM programs. So
okay.
So it should be able to be used together with your biocontrols. Yeah.
Thank you for that, Sam. And just one comment from Jonathan about Eradicote Max. He's put on the chat. It's now authorised in all outdoor and protected situations.
Okay. Yeah.
Okay, so just for information there. So thank you, Jude, for that. If I can now ask David to pick up the baton, and we're moving from pest control to weed control. So David will be updating us on narcissus, cut flowers, and the interaction between herbicides and growing media. So if you're ready, David, over to you. You're on mute, David.
Sorry about that, Wayne. Right, good. I've just pressed screen share, so hopefully you'll see my presentation in a moment, but I can't see it yet. But
no, we can see the first slide is there.
Okay, right. It would be I can't see it on mine. It would be helpful too. Jude, presumably you could see yours on the screen as you were going through.
The other thing we could do, if it helps, is I could share your talk, David, and you could just tell me next slide.
Yeah, try that, Rosemary, because it's not very helpful if I can't see it. I don't know why it's not letting me see it. So.
Okay, so I've opened it, so I'll.
Thanks.
I'll share it. With luck. Okay, can you see that now?
Yeah, brilliant, great, thank you very much.
Okay, so
right,
you'll just have to tell me next slide, sort of thing.
Yeah, rightio. So, catch up on some weed controlling ornamentals here then for both the cut flowers. Well, a lot of cut flower work really. Gladioli, Sweet Williams, and daffodils. So we better get cracking because we've got a lot of ground to cover here. So next slide, please, Rosemary. So, kicking off with the first one I'm talking about is Project SP30, which was looking at residual herbicides in field-grown gladioli. And the main objective was really to expand the knowledge of residual herbicide and crop safety following the loss of Ligneron, which hit a lot of sectors pretty hard, not just in the ornamentals world, when we lost that herbicide. So some of the residual herbicides that were looked at were already authorised for use in ornamentals. Some new coded products is the case with SCEPTREplus work, and some of these were effective against common weeds for at least 10 weeks, and they needed to be persistent enough to ensure good crop establishment. So next slide, please, Rosemary. So treatments were applied just prior to crop emergence, a couple of weeks after planting, assessed at 2, 6 and 10 weeks, and very good results as far as we're concerned from this trial, with no delays in crop emergence compared to the untreated, no evidence of any crop damage or phytotoxicity caused by any of the herbicide treatments. So very encouraging. Now, gladioli are in the family Iridaceae, which is the same family as iris, and iris are pretty resistant to a range of herbicides, so that knowledge gives us a bit of confidence in the results as well here. Also importantly for this sector, there are no treatment effects on flower development or colour or stem weight, so not impacting on the finished product, the cut flower, and significant weed control for 10 weeks in 8 of the experimental treatments. So next slide, please, Rosemary. Okay, next slide, please.
No, it's not. Now it's not moving for me.
Why it's doing that?
Hang on. Let me and show and start again. So I'll go on to the next slide. And okay.
Yeah, brilliant. Thank you. So got a range of herbicides used. Senker Flow, Wing Pea and Springboks are names that people will be familiar with the best treatments available at the time of the trial being completed. Now, Sunfire was included in the trial's work, but was put on its own, not in a tank mix with anything. So although it didn't deliver brilliant weed control when used alone, just flagging up the fact that Sunfire is predominantly used for grassweed, that's where it has most of its activity. And although the weed control wasn't brilliant, the weeds in this treatment were broadleaf weeds, so then they're not controlled by that product. So just bear in mind there's no criticism of that product. It's usually used in a tank mix, but I didn't do this work, but I guess it was used on its own really to determine crop safety. So that's useful to know. So yes, as I say, potential to use it in tank mixes to improve weed control further. Just be aware when using it in a tank mix, it's probably worth checking what you're mixing it with is safe in a little trial before widespread use. Next slide, please. So moving on to Sweet Williams, as we've heard earlier today, losses can create an impact. So loss of oxidized on Ronstar, complicated weed control for this crop, and the crop is very sensitive to herbicides, so not easy to find alternatives. So a slightly different approach was taken, looking at band spraying with GPS that's successfully used in other crops, and really exploring the possibility of putting a weaker application of herbicide directly over the crop rows, and then putting a stronger mix as an inter-row treatment to address the issue and try and achieve good weed control. So some of the products here are already authorised for use in ornamentals, with some new ones, and effective for a number of weeks, and the aim was for them to be persistent enough to ensure the crop establishes nicely. So next slide, please, Rosemary. So treatments are applied within 3 days of drilling. So pre-emergence treatments prior to crop emergence. There's an inter-row treatment in 300 litres a hectare. Assessments for weed cover and crop safety at 3, 6 and 12 weeks after treatment. One thing, there was a significant delay and reduction in emergence of some of the treatments, and those listed in brackets there, Springbok, Defiant, one of the coded products, some slight yellowing, but the crop grew away from this. Where the crop had emerged, there was no major crop damage or phytotoxicity seen throughout the trial. Stomp Aqua at the maximum EMU rate is a suitable commercial treatment. It had no detrimental effect on germination. Actually, germination was better than the untreated control, interestingly, and it resulted in nearly 8% weed cover at 12 weeks after treatment, and that was Stomp Aqua used alone. Next slide, please. So I'm sure a lot of you will have experience of Stomp Aqua, and you'll know that when it's used alone, there are gaps in its weed control spectrum. So I guess that site the trial was carried out at didn't have massively high weed pressure, or I'd expect the product alone not to have performed quite so well. So just bear that in mind, and may need to think about tank mixing. And going on from that, a number of products, including 2 experimental products, appear to be crop safe. Interestingly, Stomp Aqua and Defy seems safe, but Defy alone seemed too damaging at the same rate. So that was a slightly strange and interesting result, but need to interpret that with caution. So I think it'd be a bit gun-ho to say Stomp Aqua and Defy are safe when Defy alone caused some issues. So something to look at again, perhaps on your own sites, or even think about reducing the rate of Defy a bit to build in a bit of an element of safety. But definitely worth doing a bit more on-site work there before steaming ahead. An EAMU has been submitted for a promising experimental coded product, so that's some great news. Hopefully that'll come through in the future. And just mentioning where products reduced emergence, it might be possible to reduce the rate of a herbicide without substantially affecting weed control efficacy. So again, possibility of doing some more work on your own holdings to see what's possible there. And really, it showed that applying residual herbicides as a precision band to be a useful method, opening up a broader range of actives that could be replied over crop rows as a traditional sort of spray application. So it's a technique that could be adopted to give you access to more actives, give you that crop safety that you need, and to keep the impact on the crop minimal. Next slide, please. So moving on, onto growing media here and herbicides in growing media. This was SP53. And the main objectives here were to look at different types of growing media. So we had peat reduced and peat freeze, and really looking at the performance of herbicides in those different types of media, the persistence of herbicides, and how these growing media blends affect how herbicides leached from those different blends. Next slide, please. And when I say leached, we're thinking of leaching with rainfall and irrigation, overhead irrigation. So it was really evaluating, as we move to peat reduced and peat free blends, how this impacts on herbicides and the way they behave in the growing media we're using. So 4 mixes, 1 peat based, 70% peat, a 50% peat reduced mix, and 2 peat frees. looked at 3 herbicides that are commonly used within container sector, so Flexstor, Dual Gold and Sunfire. Flexstor's on label use, Dual Gold and Sunfire EAMUs. So 2 litre pots were used outside with overhead irrigation, and they were engineered into collection containers so that all leachate was collected, and it was tested after 1 week after treatment and 17 weeks after herbicide application. Now, before the 17-week application was tested, the collection vessels were emptied at 16 weeks, and the pots replaced in them, so we were sure that the leachate collected was collected in that week prior to testing and was relevant, and only the liquid, which was the leachate, had got to go through the media to get into the collection vessel. Also, there's another sort of aspect of this trial with an efficacy component in the different blends, using cress, annual meadowgrass and hairy bittercress as test subjects, so 1 and 14 days after herbicide application. So next slide, please. So different results with different products, interestingly, but as you'd perhaps expect, with the Dual Gold, the grown media components didn't seem to impact on persistence or performance of the active. High levels were found in the leachate after 1 week, with no traces after 17 weeks. So perhaps not that surprising, really. It's a herbicide that we can only use in May under the EAMU, and that's to do with protection of water. So knowing that it leaches quite readily it backs up the logic behind that, and it's not a herbicide that persists for that long, so again, no surprise we didn't find any after 17 weeks. So Flexstor, one of our industry mainstays, one of the few we got left. Interestingly, significant difference between the 4 grown media blends for both sowing dates. The highest amount of cress germinated in the 70% peat blend, and the lowest amount in the peat-free blends, which is interesting. We know with herbicides, some soils in very high in organic matter can reduce the efficacy of herbicides, and obviously the peat-free blends are high in organic matter, but maybe the organic matter's interacting in some way differently with the herbicide, so we can't quite explain that at this stage, but it's an interesting observation. Levels of this active after 1 week were relatively low compared to the other 2 herbicides assessed, so it indicates it's less prone to leaching, and we recovered it after 17 weeks in all 4 blends as well, showing that the Flexstor persists and persisted in all 4 mixes. Persistence and performance should not be adversely affected by the different grown media blends that this active's used in. And as I said earlier, weed control appeared to be better in the peat-free product compared to the 70% peat-based blend. So then moving on to Sunfire suggests that different growing media components didn't impact on the performance of this herbicide. High levels found from all 4 growing media blends, although the one peat-free did appear to be reducing the losses of flufenicet. So a bit of a link there between the peat-frees with the Flexstor and the Sunfire, interestingly. But with this herbicide, no traces in any blend after 17 weeks. Again, not a great surprise. It's not that persistent a herbicide. So next slide, please. So the conclusions, different growing media blends do not appear to impact on the persistence or performance of Dual Gold or Sunfire. And there does appear to be an interaction between growing media blend and Flexstor with reduced emergence of test, well, we use cress and weeds. in the peat-free blends. Leachate appears to be related to the solubility of the active, so that seems to be more of a factor than any sort of association between the media and the active, but this is really less clear. So it's been a very useful bit of work, I think. I think when it was talked about and put together initially, there was concern that herbicides may leach through peat-frees more than the sort of peat-based standards that people have been used to working with, and thankfully that's not shown to be the case. So I think we've got confidence that we can use herbicides in peat-frees going forwards. Obviously, it's only a limited amount of work looking at 3 actives and 4 mixes, but it's given us a bit of confidence in the future that herbicides should continue to perform pretty well in peat-frees. Obviously, it'd be nice to do more work and expand our knowledge, but that's something for another day. Next slide, please. So moving on to narcissus and some dormant herbicide treatments put on when the crop's dormant. So the objective was to identify safe herbicides for weed control in dormant narcissi, to expand options and minimise the risk of resistance develop into key actives through their overuse, really. So next slide, please. So like many sectors grappling with a limited range of herbicides for safe application during the dormant season, which had left some gaps in the weed control spectrum, which was resulting in some weeds becoming a bit problematic for the sector, and the loss of linearon impacted on this sector too, which really compounded the issue and resulted in the need and drive to find some alternatives with some similar efficacy to linearon. So this work was carried out on a newly planted crop of variety Fortune in Lincolnshire. There was some weed in the field, a lowish percentage, I think it was 15 to 18% from memory, that needed addressing. When I say percentage cover, that needed addressing before the residual herbicides went on, because most residual herbicides don't kill existing weed, particularly if it's large and established. And it's a double whammy really, because not only do you not kill that weed, but that weed acts as a bit of an umbrella protecting the soil from the residual herbicide. So even if you hand weed that soil underneath hasn't been treated, or the weed dies or whatever, so weed presence at the time of residuals will always reduce the effectiveness of your weed residual treatment. Anyway, the treatments were applied in 200 litres a hectare here on 21st of November, and a second application was put on to a couple of the plot treatments again in January as a top-up. Assessments, 5 assessments over various weeks after treatment, and that was really looking at weed cover, percentage weed cover, the weed species present, and crop phytotoxicity, so any crop damage. So next slide, please. So all treatments significantly reduced weed cover for up to 16 weeks, which is a very encouraging result. And no significant effect on crop quality, and by crop quality, leaf height, number of buds per metre, and flower quality and size were assessed. I say no significant effect, but there was a bit of an issue with Hurricane SC, diflufenican, which resulted in significantly less emerged leaves at the end of January. However, this didn't result in any significant reduction in number of buds per metre. It was a bit of an issue with Hurricane, but didn't seem to affect on the cropping. The active is known to be persistent, and this may have delayed that leaf emergence. The Hurricane was tank mixed with wing pea, and I just wanted to flag up the fact that there was 0% weed cover at the 16-week assessment, which is pretty fantastic really. So it's weighing up whether that later leaf emergence, how much of an issue of it does it reduce photosynthesis and affect the crop in sort of future years, or can you live with that for the good weed control that it's delivering? Another option round things might be to sort of look to reduce the rate of hurricane a little bit, although it was a fairly low rate, to address that. But if you can live with it, I wouldn't reduce the rate, because obviously you run the risk of creating issues with herbicide resistance then. So that aside, all treatments considered safe to apply as dormant season treatments. So some nice results there. Next slide, please. So, as I said, all treatments significantly reduce weed cover and were considered crop safe. Metabromuron Praxim was identified in the trial as a useful and safe alternative to linuron, and when tank mixed with products like Sencorex Flow, Stomp Aqua, so that's addressed some of the trial objectives to find that linuron replacement and alternative. Nirvana was safe but hadn't been tested in tank mixes, so worth doing some work on that if you're interested in using that product. And EAMUs under consideration for one of the coded products that showed potential, so fingers crossed there. And AHDB, another coded product, the 994, which helps plug some of the gaps in for some of the challenging weeds. That's in discussion to see if an EAMU is possible. And finally, for the last coded product, 9917, AHDB are meeting with a company to discuss potential for an EAMU. So potential of 3 new EAMUs there. We might not get them all, but it's good to hear that there's some potentials coming through, reassuring. Okay, next slide, please. So the next one was focusing on Narcissus post-cropping, so after the picking of the flowers, looking at herbicides that were safe over foliage, really, to expand the limited range of options there. So next slide, please. This trial was based down in Cornwall on variety Lowen, and 15 treatments applied in March after picking in 200 litres of water. Assessments at 2, 4, 6 and 10 weeks after treatment, and that was looking at weed cover and crop damage phytotoxicity. Next slide, please. So some good results here as well. 10 of the treatments resulted in significantly lower weed compared to the untreated. Some good results with wing pea and lecter, and they reduced weed cover by 75% compared to the untreated control, and gave a significantly greater reduction in percentage weed cover than the standard treatment of curb and Stomp Aqua. So again, potential to improve there, which is good. Some of the coded products again coming to show some promise. 9865 effective and safe, no adverse effect of foliage in the year of flowering and in the year of application, and looking at flowering the following spring. So that's good to hear and reassuring. AHDB 9921 resulted in marked wilting and collapse of the leaves, so quite an issue there, and some significant crop effects were seen with Butraflow and 2 more coded products there, which resulted in premature and early senescence. Next slide, please. So moving on to our conclusions, as I said, the wing pea and the lecter and the AHDB coded 9865 into row provided effective weed control, crop safe, applied post-cropping. An EAMU for AHDB 9865 has been agreed and is in preparation, so hopefully that one will come through the system, just a matter of time, hopefully. 10 of the treatments resulted in significantly lower weed control, and that was for 10 weeks after treatment, and reduced weeds by at least 40%, so good reduction in weeds there. And as I said, 2 of the coded products and ButyFlow resulted in earlier senescence in untreated controls. But some of these products we shouldn't discount, because you may remember some of these codes from the previous one I was just talking about, the dormant season treatments, where AHDB 9994 was proved safe when the crop is dormant. So it has, and that's one that's got potential for an EAMU. So like anything with herbicides, it's placing the right product in the right place at the right time in the crop's growing cycle to get it to work. AHDB 9921, not safe at this growth stage, but again, like I've just said, this one was safe when used as a dormant treatment, so definitely not one to be discounted by the sector if it comes through. It's just getting the timing and the placing correct to get the results from it and not cause any issues. Next slide, please. So some thank yous. Thank you to AHDB for funding this work and the important programme of developing the EAMUs, which the industry's become so dependent on. ADAS colleagues and growers for hosting the trials. And I'll just drop the link in there, which takes you to a link of all the sector research trials, and you can click on them by project number and read the reports at your leisure and in full. So hopefully that's useful to people. Next slide, please. And that's me done, really. So any questions?
David, we're going to have to leave it there because you've overrun quite a bit. So we need to move on to Selçuk's presentation now to keep on time.
Yeah.
So if there are any questions, if we can take them at the end on herbicides, please. So Selçuk, if I could ask you to, excellent, if you could start your presentation. This element is a slightly different project. It's not SCEPTREplus per se. You're just on presenter mode there, Selçuk. You need to sort of move on presentation. So this is work from the Cut Flower Centre, which was not SCEPTREplus, and it's focused on cut flowers, but I think you can see the potential there to extrapolate to other crops, and obviously downy mildew control is an issue on other crops beyond column stock. So I think we can use some of the information there to hopefully give us better control of downy mildew and other ornamental crops. Just wait for Selçuk to sort of move back to presenter at the moment. So yeah, that's fantastic. Thank you, Selçuk. So if I can hand over to Selçuk and we can look at herbicide evaluation in peonies and downy mildew control in column stalks. Thank you.
Okay, thanks, Wayne. I hope you can now see my screen and you can all hear me well. Without any further ado, I'm actually going to go straight into this, try and explain what we've been up to in the last year or so. Starting off with peony herbicides. We conducted this trial purely on the basis of phytotoxicity evaluation, just trying to understand the sort of herbicides that we wanted to get a much better sort of safety profiles and understanding of how they perform at the timing that we've tested. Obviously, spring application before the shoot elongation stage for peony crops, effectively prior to vegetative growth on peonies. We were looking to find a product with the widest possible approval, existing approval for ornamentals out there under outdoor ornamentals, as well as pretty good wide range of weed species controlled by the herbicide products that we've tested. Ideally as well, longer lasting activity as long as possible, as most of you will probably want and need. And of course, we actually thrown some of our sort of experience on previous work on look-sees back in 2021 when we had the COVID year at that point. Obviously, you'll received the copy of the presentation slide, so I won't be talking through the whole of this table, but I'll just explain some of the mixes and the product choices. So treatment number 1 was Lecter plus Samson. Quite an interesting mix for us. We haven't used it on peonies before, and what we're looking here is the effect of nigrosulfur on the shoot stem, on the stem length, and possible impact on flower distortion. Likewise with rimsulfuron and prosulfocarb, both of these products we know have been used in the past, and some growers have actually ended up having some significant damage to the stems and leaf distortion, particularly with Defy prosulfocarb, where we have seen a lot of crinkled foliage, wide strikes through the leaves, and particular sort of vibrant pink color on some of the foliage of peonies. Treatment number 3 was Eagle, imidasulfuron plus isoxaben. Purely, we know we can apply isoxaben quite safely, but we weren't very sure about Eagle, and in previous work Eagle has shown to have some relatively good activity in suppressing mare stale, so we wanted to test that again and see whether that might have showed up again, fingers crossed, in our trial. Quantum, tribenuron methyl plus napropamide devrinol, and again we were pretty confident with this particular treatment in terms of phytotoxicity, but also the weed control spectrum of the mix is really nice and wide. And then we've added a coded product which we've tested in 2021, which proved to be very longer lasting and particularly effective with its broad spectrum weed control. Likewise, it did have very good mare stale control, equisetum control. So that was quite important for us to understand if we would see any phytotoxic effects. As a result, all products showed no phytotoxicity symptoms, which is great news. As I said, all of the treatments were applied at the same time, and that was just as the shoot elongation stage was beginning to happen. The treatments were applied on 29th of March 2022. No effect on number of stems or stem length has been seen, and the weed control obviously was not assessed because we were looking for phytotoxic effects rather than efficacy. But we did make an observation for treatment 1, interestingly enough, which gave us very good suppression of mare stale. And I'm sorry, you probably can't quite see the effect here, but basically up to here is treatment 1, and you can probably see the difference sort of the herbicide had here on the mare stale suppression. We believe the coded product needs some further testing, because although we didn't see the same effect of suppressing mare stale, we believe its EMU will be very useful, particularly for the wide range of weeds that it controls. And obviously with lack of herbicides, it's going to be another very useful tool in the box for us. So we're proposing to take that further, and conversations have been made currently with Joe to approach the manufacturer and potentially work with them on a off-label approval. Another trial that we are planning to conduct in 2023 this time is a trial that's related on post-harvest weed control, and it's sort of focused on using mainly coded products, again looking for phytotoxicity evaluation rather than efficacy. Obviously, with peonies post-harvest, we still have quite a large amount of biomass of the crop canopy in the field, and often by the time we reach middle of June, July, we see quite a significant deterioration of the herbicide layer, and a lot of weeds are starting to emerge. So we are sort of revisiting whether we can apply a contact herbicide soon after crop has been harvested, and particularly with some of the contact herbicides that you can see on the right hand side in that table. We are including a large amount of products already approved under various scenarios in ornamental crops. Obviously, some of the products here on the right hand side will not necessarily control established weeds, but perhaps if we do apply them close to harvest or just after harvest, perhaps we might have a decent level of weed control with some of these contact products. This is obviously a trial that is going to be conducted next year, but already, as you can see, there's 11 treatments, including the untreated and 2 coded products. Treatment number 3 is a coded plus an adjuvant, and then treatment number 11, it's a coded product without any adjuvants, which contains 2 active substances and is approved in America for peony crops, and it has shown very good efficacy and safety in America when applied to post-harvest treatment to peony crops. That particular coded product that I've mentioned that is approved in the US, we've actually obtained a small sample, and we've tested it on a sort of look-see basis, really just 5 peony roots on an established 4-year plant, as you can see. The effects that we've had is this sort of spotting. In this sort of timing, they were applied on 14th of May. The treatment was applied on 14th of May, just as a look-see, just to see the impact of the contact activity of the herbicide. And we ended up with these white spots on the leaves, but also quite severe stem blackening and darkening. The herbicide did actually have a very quick effect. We can see it's pretty much within 24 hours to 48 hours. And as you can see here, some of the smaller shoots were actually killed by it. However, the crop did not suffer, even though the stems have actually been, as you can see, damaged and blackened. We were still being able to harvest this particular crop, obviously, provided that the stem length wasn't impacted at that stage. We still cut the crop and we managed to get the stems. So there is potential, but I want to sort of point you towards the effects on thistles. So you can see here some of the thistles have been controlled, but unfortunately some have started regrowth, as you can see. So I'm not quite 100% sure it's going to be a particularly good product for thistles, but certainly for any annual weeds, it will be a great product to use to clean up the crops after harvest. More importantly, I will move on to downy mildew control in column stalks, purely because of some of the significant issues that we've had back in 2018, which actually saw crop losses of 40% or more in some situations on some premises in the UK, particularly in and around sort of Lincolnshire. At that point in 2018, we heavily relied on Fubol Gold, Mancozeb plus metalaxyl, and our program at the time for downy mildew control potentially sort of featured 2 possibly 3 sprays maximum in the early stages of vegetative growth prior to rosette formation and bud formation. At the moment, following on from this really severe, very virulent downy mildew strain that we've found in 2018, we're on a 8 to 10 downy mildew spray treatments per crop. So you can see the significant amount of spray applications that needs to be made to be able to control and have a saleable crop at the end. We found it in the UK and Ireland, and as well as Northern Ireland, obviously, and it happened around about first week of June in 2018. And at that point, obviously, the industry came together. There was a meeting at a nursery premises in Lincolnshire with all the growers, including the suppliers of stock, of column stocks. And we've decided to start collecting downy mildew samples and commence a testing to which we were hoping to identify the efficacy of currently approved products for downy mildew control. For most of you who know or perhaps don't know, downy mildew is very severe disease. It can show a white mold symptoms on the underside of the leaf literally overnight. So it happens very quickly. In 2018, we destroyed quite a few crops purely because the downy mildew was found by the retailers, particularly at Tesco's and Morrison's, and we destroyed crops because it was packed with no visual symptoms, and then suddenly when the retailer receives it, it receives that white, really sort of moldy foliage in the bouquets, in the pots. Therefore, we had to do something very quickly, and at the time, Wayne Brough and Linda Mason and myself got together and put the maintaining successful control of downy mildew in protected crops of cut flowers in column stocks fact sheet, which most of you perhaps would have seen. So that was really focused on trying to get the best out of the products that we had at the time. So once we started collecting the samples of the downy mildew from various locations in the country, we've tested a number of different products. So our first trial included, well, you can see the products here, but particularly a coded product, AHDC F253, which subsequently gained an EMU, and that was Ranman Top. As you can see here, obviously, Parat, Percos and Reavers gave us the highest percentage control, even though not 100%, they are still quite effective applications and treatments. For nominal and Prevacure Energy, we assumed that the control was due to phosphonate component, as we can see, and we know that propamacarb does tend to work a little bit slower, although still very useful and very effective fungicide that we can integrate into our spray programs. Subdew, we really discovered that metalaxyl in our case was not providing any control, and if you look at Fubol Gold here, obviously the reliance on Fubol Gold was mainly on the mancozeb component rather than metalaxyl here. And we've also included a product here called Signum, purely just to make sure that something wasn't happening with the downy mildew, and we had a control to know that this particular product.
Good afternoon, Josh. My name's Derek Jarman, Hale of Plants. Yeah, I'm fine. Are you?
I'm not sure if somebody's got their.
Derek, can you go silent, please? We can hear you. Sorry about that, Selchuk.
That's okay. So Signum was purely included to make sure that we had a product there that we knew that it didn't have any control on downy mildew. Following this, we've put the fact sheet together for the growers with a lot of cultural control and fertigation advice, etc. So we've just about managed to get through the main crop in 2018 with what we've put together on a bit of a last-minute basis. The year after, in 2019, we then conducted a second trial, again, sensitivity testing, just to ensure that we know which products are still providing us with good control, but equally look at some HDC coded products that we've identified working with Joe at the time. This second testing, as you can see, we've divided it into an English strain and an Irish strain of downy mildew, and the names of the product here at the bottom. We've included HDC 253 again, which was Randman top, and again it clearly underperformed, and Parat still sort of delivered the best activity. Anything that was based on dimetamorph, Parat and Revis, Parat and Percos were still the best treatment at the time. What we've discovered also was that the Irish strain was a lot more sensitive than the English strain, which potentially sort of pointed towards a different spray program in Ireland in comparison to the UK in terms of what was happening on the ground. We had a clear efficacy from HDC F260 and F254. As you can see, this is the HDC 260 here on the left-hand side, and I've highlighted the products that were really giving us some levels of control. Interestingly, we've included a coded product 259, which did not show such good effects at all, even though it was meant to be one of the best products. It didn't work as well, but we could potentially be useful for further testing in the future. So we've set that one to one side, discussed it with the manufacturer, and unfortunately we've decided that we're not going to take it forward because the manufacturer did not support it. We did have a disappointing performance from Infinito. As you can see here on the left, I did have personally high hopes for it, but it didn't seem to perform so well. And equally, the 256, 257 and 258 didn't really provide much control. Exactly the same as the first trial, we've included Strobe there, which has got an on-label approval for ornamentals, just to make sure that we include a product that doesn't have efficacy on downy mildew.
Sorry, Selchuk, can I ask if you can wrap up in a minute or two, because we've actually got to 4 o'clock now.
Yeah.
And we need to wrap up. Sorry, thank you.
Yeah, no problem. And our last and third trial obviously looked at the future possibility and potential of products. We took forward the HDC 260. Unfortunately, we've discovered that the manufacturer did not support it, but then we've included a raft of other products, including some mixtures, which have got some very reasonable future with us. Particular attention I'll draw to treatment 3, 4 and 5, as well as 8, with treatment 8 is very close to obtaining a EMU for ornamentals and downy mildew. Having taken the 3 products, treatment 3, 4, 5 and 8, we then discovered, we then set off to do some phytotoxicity trials at various timings, and no phytotoxicity has been seen on any of the crops, and testing at all timings. We've actually applied them at much higher rates, starting with a fourth times rate, double rate, and then finishing off the last treatment with a label rate, or what would be a label rate in the future. Our I'm not going to go through this table. I just wanted to give you a summary to show you what we have got available at the moment. But just to finish off the summary, the loss of Mancozeb and dimetamorph are serious concerns for us in the future. So I've put together the top line is potentially what our current frac code program would looks like, and then the bottom line really what the future potentially could look like, with particularly the coded one being the product that we can devise our fungicide spray programs for it. Work on EMU has been started on the coded product number 1, and we're also aiming to obtain a coded number 2 as an EMU in the future. 2022 season of downy mildew control on column stock was actually very good. I haven't seen any mildew in significant number or levels. However, for 2023, we do have some concerns with some of the products not necessarily being commercially available on the market potentially. And that was it from me. Thank you very much. I'm not sure I've got any time for questions, but hopefully I've managed to sort of run through things a bit quicker.
Thank you, Selchuk. If we just round up with 1 or 2 questions for any of the speakers now. I've got one in here for David. It's a herbicide question from James Walkers about what rates were the hurricane and wing pea trialled at, please? You're on mute, David. We can't hear you.
Sorry, hurricane and wing pea. That was in the daffodil trials, wasn't it? I think. Yeah. That's, as we're short of time, it's not a trial I did myself. It's in the project report, so it's probably best to follow the link from my presentation. You'll find all the information in there.
That's fine, thank you. Okay. Any more questions in either directly via raising your hand or via chat, please? Okay, well, if there isn't any questions, I'll just go to the last slide to quickly wrap up. So just to sort of say thank you to all our presenters. Thank you to Rosemary for introducing today's webinar, and thank you for Catherine and Joe for covering disease control, to Jude for the pest control, for David for weed control, and for Selchuk for covering the work from the Cut Flower Centre. Please don't forget to provide basis and Neroso details. If points are required, please email Rosemary with your details. If you do have any further questions you've not thought about at the moment, please submit those directly to Debbie at the AHDB, and she'll pass them on to the relevant presenter. And just to remind you that PDF versions of the presentations and the webinar recording will be made available in the near future on the Warwick Crop Centre, and Rosemary will send around a link to that. So just to sort of say thank you to everybody, and just to wish you a pleasant afternoon, and thank you for spending the time and joining us and for listening to the presenters. Thank you very much.
And thank you, Wayne, for chairing it.
Thank you, Rosemary.